Hi guys, let us come to our class. So in my previous video, I already told that what is meant by RC4 algorithm and how to solve the problem, and nearly it consists of the three steps, guys. So in the three steps, I just completed the step 1 in my first video, and in this video I am going to completing the step 2 and 3, guys. And the step 2 is key array generation. So already I shown the algorithm. Based on this algorithm, I am going to proving the problem here. And what's the output of the step 1 is, this is the output, guys. The same output is the input for the step 2. Now the first step is I comma j is equals to 0. Let us assume that I is equals to 0, j is equals to 0. Next thing is, well, if it is true, it's true, then just move to I is equals to I plus 1 mod 256. So in place of 256, how many number of bits we have? 8 bits we have. So in place of 256, I am going to write the 8. And initially the I value is 0, and then just add plus 1. So I is equals to 1 mod 8, that is I value is 1. Next, j is equals to j plus s of I, that means index of the I value. Nearly the I value is 0. So here index of s of 0 is 2, guys. How you are going to say that is? So this is the array, S array. So here 1, 2, 0. So this is S array 0, 1, 2, 3, 4, 5, 6, 7 and so on 7. So now S of 0 value is 2. Just write it here. It is a 2 mod 8. 2 mod 8 is 2. J value is 2. Now just swap S of I comma S of j. That means 1 comma 2. If we swap 1 comma 2, what is our output, guys? This two places will be changed. That is what we will get. 2, 7, 3, 6, 4, 0, 1, 5. So this is our S array now, guys. Now this is our S array. Then let us take that t value. T is equals to I plus j. What is the value of I, 1 and 2? Always we need to take the updated values, not for the initial values. Just take the updated values. We should not take the initial value, just take the updated values. S of 1 comma S of 2. So what is the S of 1, guys? Here this is our updated version, that is 0, 1, 2, 3 and so on. Here S of 1 is, and here so just only add the I and j value, guys, not the value of S of I and S of j. Just only add the I and j values, that is 1 plus 2, and here 1 plus 2 is a 3 mod 8, that is a 3. And the last step is k is equals to S of t. In place of t, we are going to write the 3. S of 3 value is what here? Now here it is 6. Now how many steps we are going to do like this means, guys, how many number of keys we have. So here how many number of keys we have? Only 4 keys we have. So those many times we need to follow this key array iterations. That means for those many times we need to perform this. First of all, I just assumed that I is equals to I comma j is equals to 0. And the next time I am going to assuming that I comma j is equals to 1 and again as 2 and 3. That's it, guys, because I just have the 4 bits. So I need to perform the same operation. This is the same operation. So for the 4 times, that is I and j values are of 1, 2, 3. These are the 4 times I am going to perform. After that, and that means in the third step is it is nearly encryption, guys. So in the step 3, take the plain text what we have. What's the plain text? What's the first bit of the plain text, guys? That is 1. Just write the binary form of that plain text. What is the binary form of 1, guys? 0, 0, 0, 1. Now just take the k value. K means k equals to k0, k1, k2 and so on kn. K value is k0, k1, k2 and so on kn. Now here just take the k value. K value is 6 and then write the binary form for the 6, that is 0, 110. Now just perform the XOR operation. In the XOR operation, you already know that if it is the same digits, then answer is 0. If it is different, then answer is 1. Now what is the value guys here? 7. So this is our first element. So like this, you need to find for the remaining. That means you need to find answer for remaining 3 bits. If you find the answer for 3 bits, the answer would be, so for the first thing we got 7, and for the remaining that 7, 4 and at last 5 guys. So the total value is 7745. This is our in answer what we got a value, that means the text after we done the encryption value. That's it. It is very simple guys. And the first step we already seen that how to do the key scheduling values, and that you need to perfectly concentrate on the updating values of the j. Every time you need to take the updating values of the j. Then in the second step you need to perform the iterations only based on the number of key bits you have. You just only have the 4 key bits, and the size of the key bits also should be 4 only. So you need to perform the key array operation only for the 4 times. And in the last step you can either perform encryption or decryption, but I just perform the encryption value, that means encryption process. In that process just took the plain text, the first bit of the calculate uh, plain text for separate bits. So first I took the 1 and I performed the XOR operation with the key value. What are the key value I have got in the second step? I just perform with it. It is very simple guys. Thank you for seeing my video. If you have any doubts, please let me know in the comment section.